Okay, this is a quick video on a device a friend of mine coined the poor man's Variac, which it really isn't, but it's a good substitute for a Variac if you don't have one. And I suggested it to him to make one for himself for working on his power amps, although it's suitable for using, could do to use on any electronic device you want to test. If you're going to plug something in that may short out and crash and burn, then this is the great thing to do, is to use this device, which is simply an extension cord, and then you cut one conductor of the extension cord and put the light through it. So the light's in series with the outlets at the end of the extension cord. You've broken one conductor, put the light bulb on the two open ends of the open conductor, so your lights are in series. And that's it. Simple as that. And what will happen if it's running correctly, say an amplifier, this is a 60 watt amp, I've got a 60 watt bulb in, good approximation, and the response you want to see is something like that. That's exactly what you want to see. The bulb flashed bright because these caps had to charge, these two big filter caps had to charge up. It only took an instant to do that, and after they were charged up, the current draw disappeared because the amp's running normally. It's at idle, it's not really drawing hardly anything. 50 milliamps idle current. So it's a good break because if a short develops, it'll save a great deal of stuff burning up, hopefully. And like I said before, or like I was implying, it's not only good if you don't have a Variac, but even if you do have a Variac. I built my Variac on this board, and I got the socket actually wired in series with the switch. And I use a fuse, try finding this fuse anywhere. 6 1/4 amp fuse. I can put a fuse there, which I normally use, or I can do my light bulb trick with this guy too. And I can switch her on, slowly crank her up. See, I might as well try it. Or I can have it set like it is right now and turn on all at once. But if you really thought I was going to short, you'd crank it up slowly. But again, this is the response I want, this quick flash. It flashed and dimmed right down. And that's how a normal amp should work. If this light stayed bright, I know I got a problem. I'm drawing more current than I should. Okay, let's say my amplifier developed a real nasty short right across the power supply. Power supply is shorted. See, like before I got a real dim flash and then it dimmed right out. Now I can't crank it up at all without the light being bright. And the light is saving my rectifiers from burning out right now because they're working into a dead short. The only thing that's really saving this amp from power supply from crashing and burning is this light's breaking most of the voltage off. Makes a good break on your input power. A couple hints on making a simple one like this. I used this tree, a couple of these little two-ways, so I can screw in one bulb at a time to use it as an on-off switch. And I also have a 200 watt bulb here for testing bigger things. And this is 100, probably 150 because it's a three-way bulb. So I got a range here, and if you're going to build this, you probably want to collect some bulbs before they take them off the market. They're going to take these bigger incandescents off the market. And having a 200 watter, which is really hard to find, is nice because for testing something bigger, you'll need it. But this way I can adjust how much of a break I want to put on this situation. And if I was going to do it from scratch, I'd get a ceramic socket like this, and you can put any size bulb you want in there. And I'd probably buy like an air conditioner extension cord and just split the one conductor, because it's like a three-way zip. So just split one of the outside conductors, preferably the hot side, and then splice your bulb in there. But that's the basics of it. It's just a good way to prevent a big short from causing a lot of damage.